In the last screencast, we talked about how the arrow of time described the way certain things happen, and the example we gave is that if we have a bouncing ball, it exchanges energy with the surface and eventually comes to rest. And this is something that we know time goes in this direction, not the other direction. Where we're going to introduce a little vocabulary here is we'll talk about a process that is spontaneous. And a spontaneous process, we're going to say, is one which naturally happens. In other words, a spontaneous process is one that naturally flows along with the arrow of time. And so it's something that looks like it makes sense. If we see the ball bouncing and stopping, that's spontaneous. If we saw the reverse happening, we'd say that's not spontaneous. Now, how is this related to entropy? Well, we're going to define entropy this way with something that is the second law of thermodynamics. And the second law of thermodynamics says that we can divide up processes into basically three categories. If we look at the change in this quantity, which we call entropy, and entropy will have the symbol S. The change in entropy for the entire universe has to be positive for a spontaneous process. So we look at this for different processes. We can imagine something where the delta S of the universe is positive number. And in other words, the entropy of the universe went up. We say this process is then going to be spontaneous. We can imagine a process for which the reverse is true. The entropy of the universe goes down. Well, this would be an impossible process. And finally, just on the border between them, we can imagine a process for which the entropy of the universe is zero. This we will call a reversible process. So there's no driving force to make it go forward, but then again, there's none to make it go backwards either. And we can also call a situation where we don't have any drive to go forward or backwards, we can call this being at equilibrium. So if a system is at equilibrium, changes. So if a system is at equilibrium, neither the forward or reverse direction will be spontaneous.